Good afternoon, everybody. I know the time is closer to the lunch time, and we have one more speaker. So, I don't have a presentation to be made, but I thought should share some insights. All of my colleagues, incidentally, I am an alumni of this institute, so it's an nostalgic moment to be back here after 35 years. Passed out in '89, and Dr. Kandan from IOC was 1 year senior to me in the same metallurgy department. So we all share the same pain areas. I am sure Dr. Jaya will also share the same pain areas, right? So we talked about a lot of big things, right? And sulfur corrosion and naphthenic acid corrosion and other things. Still, there are many areas which we struggle. I am not disturbed in my day-to-day life because of these problems. My day-to-day problems are more in cooling water corrosion. Right, even though we have the best of our chemical treating companies putting all kinds of chemicals, the type of water changes. We use desalinated water in one plant and we use river water in another plant. But irrespective of the water, the river water, and some days because of the summer season, the Narmada river dries up and the sea water backs up to the point where even up to 70 kilometers into the land. So my takeoff point of the fresh water is having, suddenly you find out it's having 1000 ppm chlorides instead of a normal limit of 300 ppm, and you cannot shut down your plants, and your infrastructure is not designed to handle this. So most of the time we spend in managing water related corrosion. Fire water was one of the points that was touched upon by somebody here, right? So for the huge losses into the underground, all the fire water, because of insurance, it's underground. Because when there is a real fire, you need water to fight the fire. So all the pipelines are put underground. So you need water to fight the fire. So, but all the pipelines, they become aged because you don't see them. So you don't see them corroding. You really don't know even that you are losing water into the underground. How much water is being lost is also not known, right? So, and it's all older systems. It's buried under concrete. No inspection is possible, and no robots can go there. No drones can go there. Right. The third area of the water, what we still have, I am sure some NTPC people are here, that's what I heard. Simple condensate, boiler feed water, and steam. A lot of problems in these systems. Even though we all think that we understand these systems, we understand how water corrodes steel, but we still have a lot of problems in the system. Even though my refinery people will talk to you about crude corrosion, most of the merchant refineries, Shell, Exxon could be an exception. They have a lot of in-house research capabilities, or they build certain refineries with some more investment. I am talking about merchant refineries. That means like Reliance. We buy crude, we process, we convert into products, we sell it in the market. So we are a merchant refinery. We are not basically licensing organization like Chevron or Exxon or Shell or anybody. Merchant refineries have not solved the problem of crude column overhead corrosion. Many studies have been done. We still have not solved. Every 4 years we replace pipelines. We keep trying coatings. We keep trying different kinds of corrosion inhibitors. By the time we understand, your crude slate has changed. One of the petrochemical plants, we use kerosene to manufacture LAB, linear alkyl benzene. Right? If the source of kerosene changes from BPCL to HPCL to Reliance, I have a change in my corrosion issues. Even though I have the same level of chlorides or sulfur or other impurities in my system, because the type of chlorides are totally different. The type of organic chlorides are still not understood. We all think that all chlorides are inorganic chlorides and we measure it, but I really don't know how much chlorides go into my system which is undetected, and then you only have a consequence. Right? We have petrochemical plants where we use hydrofluoric acid. The example what Mr. Mohammed was showing, right? When elbow failed, it was an hydrofluoric acid alkylation plant. Out of many elbows, that was the only elbow that was not inspected. We know that incident, what happened. Because they thought if I am inspecting 80 elbows, one elbow in between should exhibit the same corrosion phenomenon as the other elbows, and exactly that elbow which was not inspected gave away, and then there was a huge explosion. The pressure vessels were flown away by few kilometers, right? And as he rightly said, the company is out of business, right? So we use hydrofluoric acids in one of our alkylation plants. Inspecting and predicting corrosion is still a challenge. Refinery, big things have been taken care. Sulfur is taken care, naphthenic acid is taken care. But many process plants we have not taken care. I process hydrobromic acid in one of our plants, manufacturing PTA, purified terephthalic acid, which is a raw material for your polyester cloth what we wear. We have a combination of air, hydrocarbons, acetic acid, hydrobromic acid at the highest temperature possible. Combination is not known. We have stress corrosion cracking, but I don't have chlorides. It is bromide, but I am not able to prove that, because there is no research on bromide stress corrosion cracking. There are not much papers available in the public domain or even if you pay for it, papers are not available to show how bromides, what is the limit of bromides that we can accept, what is the temperature we can accept. Limits are not defined, right? One of the other challenges what we face is size, right? It's good to have an 300,000 barrels refinery, but when you have 1.3 million barrels, 1,300,000 tons of crude what you process, 1.3 million barrels per day, the size of my column inlet is 2.5 meters, 100 inches. None of the modeling works, right? The phase flow inside the pipeline is you need to do more computational analysis to find out what could be the flow regime inside a 100-inch diameter, maybe as big as this 2.5 meters, 2.75 meters diameter pipeline. These are all some of the challenges which are there. We could be having a lot of point solutions. Reliance is using a lot of latest technologies for point solutions. Like you was talking the example of coke drum, we also have a lot of point solutions to make sure that my coke drum we just spent around 100 crores to repair coke drums, so that I get another 10 years life out of the coke drums. We are just going through a coating technology for one of our process fire heaters, platformer, CTEC coating is being given. Shell must be knowing also, they also do it. 68 crores just to coat the pipeline. So there are a lot of point solutions where you know you have a problem, you have a failure, you do analysis, then you come out with a solution for that particular one. But there are many systems where we still have generic issues and we are still looking for solutions. We know a lot of universities outside India do a lot of research, right? But what I am looking forward today here is, because this is my alumni, I thought I should come here, and we are having this in an academic institute. It's not a NACE or something where it's just a combination of all group of other companies, right? So it's in academia. Yes, Reliance, companies like Reliance are interested in exploring, as Dr. Jagdish was telling, in investing money. What we need is, we should know, you should know what my problem is, and I should know what the industry facilities you have to do corrosion testing. Do you have the required autoclaves? Can you really simulate the actual conditions that's there in my pipeline or in my equipment? Can you do that same pressure, temperature, the chemistry? Do we have the so it's a multidisciplinary work. It is not a metallurgist work. It is just not an simulation work, or it is just the chemical engineers. We should come in and tell you what is my chemistry, right? And you have the testing facilities, you have the autoclaves, you have the ability to generate or simulate the condition, which is exactly, because my problem in my refinery is totally different, because the oil that comes from the ground is not the same. The Venezuelan oil is different from Arabian oil. Arabian oil is different from Bombay High, and the gas I am getting from my own oil and gas stream in Kakinada is different, right? So we are interested, but that's what I was telling Professor Jagdishan and other people. Please come to our place. We will give you a list of problems. These are all the problems. We can choose few where you feel you have the expertise, the understanding, or you can develop that understanding by doing certain level of studies. Money will always come. So if you are able to solve a specific area of a problem. Let's take cooling water corrosion. Very, very simple, right? It's not very, but we still have. I still do coating in a cooling water exchanger which is equivalent to the cost of the exchanger itself. So every time I give a recommendation, please coat this 8 exchanger with this coating, which is again coming from USA. If I spend 1 crore in buying a tube bundle, because my size of the exchangers have gone up, because my size of the manufacturing capacities have gone up. I have an exchanger which is around 6,000, 8,000 tubes. So coating that exchanger is 2 things. One is cost, another is time. Both I don't have. Right, but that 8,000 tube exchanger cannot be converted into cupronickel, right, from carbon steel. It has to be carbon steel because cupronickel is 4 times cost, 6 times, 8 times, whatever is the money that's available on that day. So cooling water is still a big corrosion. If we can work, you can come out, we can do a lot of studies and then come out with an solution on how do we check whether the cooling water treatment, what I am supposed to be doing, is it being done, or we are just adding certain chemicals, whether it is reaching my exchanger or not, or it is just getting mal distributed. If there are 50 exchangers, only 10 are getting it, remaining 40 does not getting anything. We don't know. So the modeling, the distribution of chemicals, the addition of chemicals, is it good enough if I add chemical at 1 point, maybe one output could be, no, you need to add it at 10 different points. So we are open. We need the institutes to come to us, and we will also give you the list of problems what we have. Every industry has its own sweet problems, right? And we have solutions for some and we don't have solutions for many. Let's discuss together, pick up 3 or 4, make a 3-year program. Okay, the development could call for 2 crores, 3 crores. We will see how to support that project. As long as we have a definition that we will solve cooling water corrosion over a period of 3 years, and the understanding is there, the experts are available in the academia, industry part will be given. We will give you samples, we will give you the actual cooling water treatment, we will give you the chemicals that's used in the cooling water treatment. Jointly we can study. So we are looking for that kind of an work. And one example what I can give is, I think many of them said, is IIT Madras Center for Non-Destructive Testing is one where we have successfully did this. Professor Krishnan Balasubramaniam is there. They came, even today we are working with them. Any problem we just talk to them and they develop the NDs. And then we have sponsored many projects with them. Startups have been there. Under storage tanks inspection, underwater rovers. So it's a startup project we sponsored jointly along with Indus Government of India. Similar things can be explored. We're open. I just wanted to express that. Problems are many, but I think we need to jointly find a solution. I think with all the, as you are saying, Atmanirbhar, I think when we can have world-class manufacturing facilities, I am sure we can have world-class corrosion testing facilities also to overcome the problem within our country. Thank you very much.
Yeah, please. Myself from NTPC.
Yeah.
And we are using same problem. Myself from NTPC, and I have the same problem. We are using sodium monohydrate for stress corrosion cracking. Our limit is 400 ppb. Because the cost itself is prohibitive, sometimes the chloride goes very high. So have you explored any alternative chemical to sodium monohydrate?
I am not an expert on water treatment, so I will not be able to answer this question. But yes, when you are forced, because of nature, you don't have rains, the Narmada water dam level goes down, and the farmers get the priority when it compares to the industry. Right, it's very clear.
Another question, are you using any chemicals for this thing, firefighting systems? Because lots of problems there.
Yes. Most of them are focused on microbiological, reducing microbiological.
MIC for reducing MIC. So basically you are using biocides.
Biocides, that's all.
Otherwise you have to flush out.
Yeah, because fire water is, still in India water is cheap.
Thank you.
Right. Thank you.
Thank you so much, sir, for a thought-provoking kind of a talk, I would say. I fully agree with you. I think academia and industry has to walk miles, shake hands, work together. Because if you want to, probably they say that if you want to walk fast, you can walk alone. But if you want to walk far, you have to walk together. I think, thank you so much. I hope one of the outcomes of this workshop would be we would like to make a visit to Reliance with a team of people from IAC and see how we can shake hands and move forward. Thank you so much, and please join me in thanking Umakantan again.